Hi, my name is Norm Hinman. I'm the president of SiOptions LLC, and I'm here today to talk to you about the dependence of our food industry, the food system worldwide, on fossil fuels and what we can do to try to decouple this important and valuable industry from the use of fossil fuels. Most people don't realize that the food industry worldwide consumes about 30% of all the energy consumed in the world. Moreover, it contributes about 20% of the global warming gases to the atmosphere each year. So it's a huge consumer of energy and a very significant contributor to the global warming issue. The thing about the food industry, the agricultural industry, is that although it is a large consumer of energy, it is also a very significant producer of energy. However, this energy that it produces is largely in the form of agricultural residues. Now, worldwide, the big crops are, of course, corn, wheat, and rice. Each of these produces annually about 1 billion tons of dry agricultural residues. It's a huge resource with a lot of energy in it. The problem is we're not using this resource in any kind of economical way, and currently a lot of it's just simply burned on the field. A lot of it's used for very low value applications. The purpose of my company and the focus of my company is to find ways to use this huge resource to develop energy products and other products to help the food industry to decouple itself from the use of fossil fuels. Our process starts with, at the beginning, with the extraction of most of the minerals, such as sodium, potassium, magnesium, calcium, phosphorus, etc., from the ag residue, so that we create a very pure agricultural material. The minerals can be returned to the field so that we don't deplete the field of minerals, so that there are minerals there to support the next crop of biomass. That extracted material is then fed into our gasification process. It's a proprietary process that produces a very clean, high energy content fuel containing to a large degree methane. The energy content is approximately 500 BTUs per standard cubic feet. From 1 ton of biomass, typically we can produce about 19,000 square feet of standard cubic feet, of gas, and multiplied by the energy content per standard cubic feet, that means we're producing from a ton about 11 million BTUs per ton. A piece of the picture, a quality of the gas, is that it contains no tars. This is very important. A lot of gas products made from biomass are contaminated with tars, and it costs money to remove those tars because the tars can be problematic for downstream equipment and for conversion equipment. Our gas is free of tars, and that's a real advantage. What that means is our gases can be used in a variety of energy conversion systems, namely internal combustion engines, can be used in steam power plants, can be used in gas turbine power plants, can even be used in fuel cells. So it's a very clean fuel that can be used in a variety of energy conversion systems. The question is, okay, if we were to use this technology to make this gaseous fuel product, how much fuel could we make? How big of an impact could we make on the worldwide food system? Well, if we were to convert all 3 billion tons of ag residues in the world into this gaseous fuel, the result would be a fuel product in total containing about 30 exajoules of energy. The food industry at large consumes about 95 exajoules. That means if we were to take it to the limit, we could replace about 30% of the fossil fuels being used in the food industry today. Now, of course, we're not going to take it to the limit. That would be impossible. But let's say we use only 18% of the ag residues in the world to make this gaseous fuel. If we were to do that, we could produce about 6 exajoules, which is the total amount of energy needed for all on-farm applications worldwide. So in other words, using 18% of the residues in the world, we could basically replace the amount of the fossil fuels being used for on-farm applications. And at the same time make a significant impact on the amount of global warming CO2 in particular being released to the atmosphere. Now, in the case of corn and in the case of wheat, besides making this high-value gas product, we also make a char material. We envision using the char to provide energy back to the gasification process. In the case of rice, we also make a char product, but this char product contains a high level of silicon dioxide. The rice plant is very unusual in that it typically contains anywhere from 10 to 20% silicon dioxide. And so the char we produce ends up containing silicon and carbon, and we can adjust our gasification process so the ratio of silicon to carbon is well suited for some other applications that I'll describe in just a moment. In addition, this char, this silicon-containing char, is extremely pure because we have already removed up front essentially all of the minerals from the ag residue before it enters our gasification process. So we end up with this extremely pure carbon silica material, which is ideal for producing very pure silicon, Si, for making photovoltaic panels. It's also ideal for making silicon carbide and silicon nitride, two very valuable ceramic materials which have some incredible future uses. And so, and we have developed technologies to convert this very high value char silica containing material into these downstream silicon products, namely silicon, silicon carbide, silicon nitride. So in that way, you can see that using rice residues in particular, not only are we producing this high quality fuel, but we're also producing a material which will support the development of the photovoltaic industry, another source of energy to the food industry to help decouple it from the use of fossil fuels. So that's our vision. That's what our company's all about. I hope it's helped you understand what the issue is, how I see the whole issue with regarding decoupling this industry and what we can do, what our company is trying to do and can do to help that happen. Thank you.